Okay, group 3, you may now start.
Am I audible, ma'am?
Yes. Okay, go on.
Start na, ma'am. So, good morning, everyone. We are the group 3. So, we will be reporting about periodic table of elements, and the objectives are illustrate the modern periodic table of elements, and also we will be defining terminologies associated with the elements in the periodic table, and also we will predict the number of protons, neutrons, and electrons of the elements and or ions. So starting, we will be discussing about periodic table of elements. So the periodic table of chemical elements, often called the periodic table. It organizes all discovered chemical elements in rows that we called the periods, and also for columns, we call it as groups, according to increasing atomic number. So scientists use the periodic table to quickly refer to information about an element like atomic mass and chemical symbol. So next slide, please. So this is our periodic table of elements. And then it is the modern periodic table of elements. So for the next, the definition of terms, I will be giving the stage for Mr. Magallanes.
Hello po, ma'am. Good morning. I will be discussing definition of terms like the atoms, ions, protons, neutrons, electrons, atomic number, atomic weight, family or group, and period. Next slide. So for the atom is a small invisible particle considered as the basic unit of matter. An atom consists of three main subatomic particles, namely protons, neutrons, and electrons. For protons are positively charged particles located inside the nucleus. Electrons are small negatively charged particles that spin around the nucleus. Neutrons, which are also located inside the nucleus, have no charge. And ions are atoms or molecules that have a charge, meaning the protons is not equal to the number of electrons, giving the atom either a positive or negative charge. For the next slide, atomic number is equal to the number of protons inside the nucleus. And it is also the number of protons in an element. For atomic weight, it is the average mass of atoms of an element calculated using the relative abundance of isotope in a natural occurring element. Next slide. Family or group. A family is a group of elements with similar chemical properties. Like for example, group 18. Group 18 is also known as noble gas family. Noble gas family. Ito sa kilid. So ayun. For period, is a horizontal row of the periodic table. Basta parang nandito ito. So I think that's all for my report, and I will be giving the stage for Miss Villanueva.
Thank you, Ayan. So good morning, everyone. I will be explaining on how to predict the number of protons, neutrons, and electrons. Before we proceed, let us first identify this element. So this is the atomic number. The symbol the name of an element, which is boron, and this is the atomic mass. Next. Okay. Let us first talk about the formulas that we need in order to calculate the number of protons, neutrons, and electrons. So let's start with the number of protons. This is always equal to the atomic number. That's it. So, example, we have boron earlier, is 5. So this will be our protons. Now, the number of neurons is the difference between the mass number and the atomic number. And then the number of electrons is equal to the atomic number minus the charge of the species. So for an atom, let's say like aluminum, which doesn't have a charge, and so it means we have a 0 charge. What is the atomic number of aluminum? Wait lang. So, if ano yung atomic number ng aluminum, yun din yung kanyang electron since walang charge. So we have 13 pala ito. 13. So next. Let's focus muna dito sa charge before we proceed para merong clarity sa table na given. But if we have an ion, let's say a positively charged cation, in this case, there's gonna be 3 more protons than electrons. Or if we have an anion like the phosphide, there's gonna be 3 more electrons than protons. So take note, if we are saying cation, it is a positively charged atom, while an anion is negatively charged. So correct me if I'm wrong. Next, we will proceed now. So for this first item, we have copper, and this is our atomic number. So the proton is equal to the atomic number, which is 29. And for neutron, we will just be subtracting the atomic mass to the atomic number, and that will give us 35. So for the electrons, since we do not have any charge, the proton and electron is just the same. And the process is just similar to number 2 and 3. We have the same we have the same proton and electron, which is 33. And for the neutron, 75 minus 33, and that will give us 42. For hydrogen, we have 1 proton and 1 electron since there's no charge, and for neutron, we will just be subtracting the 1 and minus 1. For chlorine, we have 17 proton and electron, and for the neutron, 35 minus 17, that will give us 18. Now let's proceed here to number 5. I have mentioned earlier about the charge. Since we have positively charged here, the electrons is lesser than the number of protons. So the atomic number will is minus the positively charged, and that will give us 10. For the neutron, we will just be subtracting 23 minus 11, and that will be 12. Now here for the oxygen, we have 8 proton. This is the atomic number. And for the neutron, just subtract 16 minus 8, and that will give us 8. And for the electron, we will be subtracting 8 minus negative 2. That's why we have 10. And for the aluminum, we have 13 neutron, proton, rather. For neutron, we have 27 minus 13, and that will give us 14. And for the electron, we will just be subtracting 13 minus positive 3, and that will give us 10. So any question for clarification, or clarification rather?
We'll check later ha. Later na lang. Isahin ko
Okay,
na.
ma'am. So I guess we will be proceeding for the next reporter, which here.
So I'm the next reporter. My name is Brian Calgilat. So I'm going to discuss the history of the development of periodic table of elements. So chemists have always looked for ways of arranging the elements to reflect the similarities between their properties. The modern periodic table lists the elements in order increasing the atomic number or the number of protons in the nucleus of an atom. So a number of other chemists before Mendeleev were investigating patterns in the properties of the elements that were known at the time. The earliest attempt to classify the elements was in 1789 when Antoine Lavoisier grouped the elements based on their properties into gases, nonmetals, metals, and earths. Several other attempts were made to group elements together over the coming decades. In 1829, Johann de Bruyner recognized triads of elements with chemically similar properties, such as lithium, sodium, and potassium, and showed that the properties of the middle element could be predicted from the properties of the other two. So, next slide. So the first contributor in our periodic table of elements is Alexander Emil Cortes. I don't know how to speak his name, but he was a French geologist, but this was at a time when scientists specialized much less than they do today. His principal contribution to chemistry was the base telluric or the telluric screw, a three-dimensional arrangement of the elements constituting an early form of the periodic classification published in 1862. The telluric screw plotted the atomic weights of the elements on the outside of a cylinder so that one complete turn corresponded to an atomic weight increase of 16. Next. So the next person is John Newlands. Just 4 years before Mendeleev announced his periodic table, Newlands noticed that there were similarities between elements with atomic weights that differed by 7. He called this the law of octaves, drawing a comparison with the octaves of music. The noble gases, such as helium, neon, argon, etc., were not discovered until much later, which explains why there was a periodicity of 7 and not 8 in the Newlands table. So, nakalimutan ko po lagay yung table in Next slide. So, next we have Julius Lothar Meyer. His first table contained just 28 elements po, organized by their valency, or which means how many other atoms they can combine with. These elements were almost entirely main group elements. But in 1868, he incorporated the transition metals in a much more developed table. This 1868 table listed the elements in order of atomic weight, with elements with the same valency arranged in vertical lines, strikingly similar to Mendeleev's table. So we have the Dmitry Mendeleev. So Mendeleev discovered the periodic table, or the periodic system as called. While attempting to organize the elements in February of 1869, he did so by writing the properties of the elements on pieces of card and arranging and rearranging them until he realized that by putting them in order of increasing atomic weight, certain types of element regularly occurred. For example, a reactive nonmetal was directly followed by a very reactive light metal and then a less reactive light metal. Initially, the table had similar elements in horizontal rows, but he soon changed them to fit in vertical columns as we see today, just like this arrangement. Next slide. So the last one po is si Henry Mosley. Ito po yung final person. So it wasn't until 1913, 6 years after Mendeleev's death, that the final piece of the puzzle fell into place. The periodic table was arranged by atomic mass, and this nearly always gives the same order as the atomic number. However, there were some exceptions like iodine and tellurium, which didn't work. Mendeleev hadn't seen that they needed to be swapped around, but it was mostly that finally determined why. So si Mosley po talaga yung final person na nag-arrange po ng ating modern periodic table of elements. So that's fine.
Good morning, everyone. I am the last reporter. So, how are the elements named? So, according to the IUPAC, elements can be named after a mythological concept, a mineral, a place or country, a property, or a scientist. Official element names and symbols are determined by the International Union of Pure and Applied Chemistry. However, elements often have common names and symbols in various countries. Elements don't gain official names and symbols until after the discovery has been verified. Then a name and symbol may be proposed by discoverer. Some elements group have naming conventions, like halogen names end with INE, except for helium, noble gas names end with ON or ON, and most other element names end with IUM. And next slide. So where did the symbols of the elements derive? So chemical symbol or short notation derived from the scientific name of a chemical element. Example, S for sulfur and Si for silicon. Sometimes the symbol is derived from the Latin name. Example, Au for aurum stands for gold, and Na for natrium stands for sodium. So the present chemical symbols express the systematizing of chemistry by the atomic theory of matter. The English chemist John Dalton, who followed the alchemists in representing the elements pictorially, made the important advance of letting his symbols designate single atoms of elements, not indefinite amount. So that's it.
That concludes our reporting, ma'am.
Okay, can you go back to the slides predicting the numbers of subatomic particles? Let us check once again. So please take note of this, ha. Ayan. So again, we have here 3 subatomic particles class. Do not forget, pag maingon mo proton, that's the positively charged. Neutrons, they don't have charge, so they are neutral. And lastly, we have electrons. They are the negatively charged subatomic particles. So the given here can be element or a neutral atom, walay charge, or ion. So ang ions class ha kay kanang naay charge na atom. So you can actually see it directly sa given kasi meron silang charge, either positive or negative. Now, this is how, i-review ko lang, this is how again you can predict the number of subatomic particles. For the number of protons, always look at the number, the atomic number. Let me delete this. Again, for the number of protons, it is always represented by the atomic number. Ayan. And then for the number of neutrons, always remember, our formula here is atomic mass, or other names sa atomic mass class, mass number or atomic weight. Pareho lang na sila. Minus the atomic number. So pag moingon magugkaog atomic mass, it represents the combination. Combination na sila sa protons and sa neutrons. That is why to get the number of neutrons, i-minus lang nato. Tanggalo nato ang number of protons and the number of neutrons ang mabilin. And for the electrons class, diri sila magkalahi kasi we have rules here. If neutral ang atom, meaning if walay charge ang atong element or ato ang atom, the number of electrons is the same. Equal lang siya. Number of protons is equal to the number of electrons. But dito na siya maglahi pag naay charge. So later, we will discuss how to predict again the electrons, the number of electrons if charged ang atong element. So let's see if tama ni again ang inyuhang mga gipangsulat dinhi na mga numbers. So if na-confuse mo class kung asa dapit ang atomic number o asa dapit ang atomic mass, always remember na most of the time, and actually most of the time yun except for hydrogen, the atomic number is lesser compared to the atomic mass. Lesser gina siya kay proton lang man iyahang gina-represent. Tapos si atomic mass duha man, proton and neutron. So ana na lang para madali ang atoang life. So for the number of protons, this is correct, 29 because that's the atomic number. Tapos for the neutron, 64 minus 29 is 35. So this is also correct. And since wala tayong charge for copper, so number of protons is the same with the number of electrons. And then this one, arsenic, I think di pa correct ni siya no kay 23 tong nakabutang sa activity, but that is just actually a typographical error because the correct atomic number for arsenic is 33. Thus the correct answer here is 33 also. And then 75 minus 33 is 42. So this is correct. And then this is also correct since walang charge si arsenic dyan. Now for number 3, so this is 1, and then parehas man sila 1. So this is the only thing na nagpantay. This is the only example na nagpantay si atomic mass o si atomic number kay hydrogen. So 1 minus 1 is equal to 0. So walay neutron class si hydrogen and wala man siya charge. So this is correct also 1. Now for chlorine. Chlorine here has no charge. Yes, Ayan?
Ma'am, yung sa arsenic, good ma'am. Yung sa bigay mo na activity, 23 yung nakalagay dyan, ma'am. Hindi 33. I-correct na lang namin, ma'am.
Sige. Yeah. Correct lang ninyo kay na typographical error dito. Okay. Sige, we have protons for number 4, 17. And then 35 minus 17 is 18. And wala siyang charge, so this is also correct, 17. Now, for sodium, so mo na ni siya karon class ang naay charge. So pag naay charge, pareho lang gihapon ang protons ug neutrons, ang electrons lang ang maglahi. So this is still correct, 11. This is also correct, 12. Pero for the charge, ang inyong tandaan, 23, 11, sodium positive. So you will look at class the charge, we have their positive 1. Ang tandaan ninyo, pag positive gani ang charge sa atuang element, it means it has more number of protons. Again, mas daghan ang iyahang protons. Pero wala man na nato gina-change ang atong number of protons. So dito ta class mag-adjust kay electrons. So positive 1 man na siya. It means it has 1 more proton compared to the electron. So if ang sodium has 11 protons, meaning naa siya'y 10 ka electrons. That's how you predict the number of electrons if it is positively charged. Again, the positive charge there denotes that you have more protons than the electrons. But do not again change the number of protons kasi wala na siya nag-change class, always yun na siya sa iyahang atomic number. Now, paano sa number 6? 16, 8, oxygen, -2. Again, the same number of protons, it's still 8. It is still represented by the atomic number. And then ang neutrons po, atomic mass minus atomic number. So 16 minus 8 is 8. But we have a charge here na negative. So the negative class there represents that you have more number of electrons. So dili na magpantay ha, dili na magpantay ang protons ug electrons pag naa na siya charge. So you have more number of electrons there, actually duha kay mauman ang number nga kauban ni negative sign. So if you have 8 protons and naa siya negative nga sign, meaning mas daghan daw iyang electrons ug duha, so it means 8 plus 2 is equal to 10. So I hope nasundan na siya. And then, lastly, we have another positively charged ion here, aluminum. So 27, 13, Al, positive 3. Protons are the same, 13 gihapon na siya. Tapos 27 minus 13 is 14, so this is still correct. And again, the positive here denotes that you have more number of protons. So if your protons are 13 here, tas mas daghan daw siyang tulo, so 13 minus 3 is 10. That is the number of electrons. So kinsa ang wala nakasabot ani nga part? Anyone? So I hope nasabtan to. Any question? So I think that's it for the report of the group 3. So thank you group 3 for reporting activity number 3 very well. So pwede na nato i-stop ang screen share. I'll have this, ato lang siyang i-discuss ulit para sa mga wala naka-catch up kagaina sa report sa group 3. So again, ito ang activity number 3 is about the periodic table of elements. Kailangan yun nato ni siya agian class because we are preparing sa uban pa na mga concepts sa chemistry. So actually, ang mga sunod na concepts kay ano na, naming na sa mga chemicals nato. So it is very important for you to know the periodic table together with the names and the symbols of the elements there. So mauna ang periodic table na activity. And also, after the naming, we will also have the making of the chemical formula. So mauna ang mga next nato na mga topic na i-discuss. So actually, I need you to familiarize that different elements found in our periodic table, ang ilahang pangalan, ug ang importante sad ang ilahang symbol, okay? Pero wala ko nag-ingon nga memorize ninyo ang atomic number ug atomic mass. Ha, wa ko nag-ingon nga memorize na ninyo basig wa na ko estudyante pagkahuman kay nabuang nag-memorize sa atomic number ug sa atomic mass. So ang ako lang gusto name sa element and then the symbol so that when we are asked to either name the compound or make the chemical formula, it will be easier for us. So mo na inyong task karon. Especially ng mga common na mga elements class, pwede na actually nga dili ninyo gyud memorize ning lanthanide and actinide series because they are called rare earth metals. So they are rarely seen sa earth, dili kayo sila ing ato kadaghan, thus wala pud kayo nato sila ginagamit when it comes to making compounds, chemical formula. Kanang naa sa taas gyud class gikan kay hydrogen padulong sa right, mao gyud na ang mga common nato na mga elements and mao na inyong familiar ninyo ang ilahang name. Okay, so this is class the periodic table of elements. Currently we have 118 na accepted and also discovered the mga elements. 118 na sila as of 2016. For example, naamo din high periodic table, tas diri gani sa baba, kaning diri sa 110 hangtod 118, ang nakabutang ka UUQ, UUB, UUN. That is actually an old periodic table. Again, that is an old periodic table because nowadays, sugod 2016, na kompleto na siya ang mga elements hangtod sa ika-118. Okay, so this is now again the modern periodic table that we have. And we classify elements, for example, kung group ang ato ang ginaistoryahan, again, di ba, ang ato ang gidiscuss man ni kagaina ni Ayan, nagpakita pa gani siya og periodic table. So we have here the so-called group. Oops, sorry. Group. Other names sa group class kay family. Again, group or family. So pag moingon ka group, it's the vertical groupings or vertical arrangement of the periodic table. Vertical, patindog, meaning kani. This one is the group 1A here from hydrogen to francium. This is the group 2A from beryllium to radium. And so on. Scandium and yttrium belongs to the same group. The same thing here also, boron to nihonium, they belong to the same group. That's the vertical arrangement in the periodic table. Group or family. But when you say period, this naman is the horizontal grouping in the periodic table. Pag mayroon kag horizontal, pahigda na siya class. So naa na siya number, kung tanawin ninyo yung periodic table din, na na siya number diri sa kilid. Mo na ang ilahang period nga number. So if you are asked how many periods are there in the periodic table, we only have 7 periods. Okay, 7 periods. So ang pagmingon mo, what elements belong to period number 1? We only have 2 elements there. Syempre, the helium going there. Hydrogen to helium. That's the period number 1. So again, that's the horizontal na grouping sa periodic table. Actually, it's still possible na madagdagan kasi we don't know, maybe after pila ka tuig na napud sila ma-discover nga new elements. So, napoy possibility na mabag-o pa ang periodic table nato. But so far ha, as of today, we have 118 elements in the periodic table. Okay? So, naka-color coding ang ato ang mga elements class. So, kanang nasa group 1A except for hydrogen, they are called alkali metals. Meaning they are all metals except for hydrogen. So, from lithium until kay francium, mga metals na sila, to be specific, alkali metals, because they form alkali or alkaline na compound if mag-react sila kay water. That's the same thing with the group 2A from beryllium to radium. They are also metals, and to be specific, they are called alkaline earth metals. Now, kanang naka-blue din ha sa tunga, from scandium hangtod kay copernicium sa 112 nga atomic number, they are called the transition metals. And that separates them from the other elements because they are our group B, or we call them family B. Kani sila tanan, kung nakita ninyo ang group 1, group 1A, group 2A, tapos nag-jump na diri group 3A, they are called the family A or the group A of the periodic table. Family A because they are the representative elements, and then kaning group B or family B, they are called the transition elements, and to be exact, they are all metals, so transition metals. Actually, including the lanthanide and the actinide series. Appeal na sila. Okay? And then, kani siya, kaning, sabi ni color orange. Wala pa man na color blind. This one is color orange here. Kana sila, they are basic metals. So definitely class, they are still considered as metals, but they are basic metals. Now, kanang naka-green, they are the so-called semi-metals from boron to polonium. Semi-metals, or we call them alloys because their behavior, their characteristic is similar to metals, but they are also similar to non-metals. So na sila sa tunga, thus we call them semi-metals. Next, we have the blue ones here, including hydrogen, including the hydrogen here, hydrogen, carbon, nitrogen, phosphorus, oxygen, sulfur, and selenium. Do not forget that they are our non-metals. But actually, kaning fluorine, kaning naka-yellow dinhi, o kaning naka-brown dinhi, the mga noble gases, actually, they are still non-metals. It's just that we separate them. Kaning from fluorine to tennessine, we call them halogens. They are again non-metals gihapon, pero to be specific, we call them halogen. And syempre, ipakita po ni Ayan gaina, we have the helium here. Pababa, we call them the noble gases. So, why do you think they are called noble gases? Anyone here knows why are they called the noble gases? Ang una makatama, +5 sa quiz ugma. Wala gatino. Maninood ba ako ana pamingon kay kog +5 yun na. Yes, Stephanie. Well, let's see kung tama si Stephanie.
Wala sila nag-react
Wala sila nag-react asa. Ha?
With anything, ma'am? Ano man?
Wala sila
Dahil lang. Ulitin sa to, wala sila nag-react with anything. Sige, let's see. Nakay answer Ayan, unsa to? Aki sa to nag-istorya na si Ayan?
same rapod ni explanation, ma'am. Wala sila nag-react po sa mga iba nga.
Stable naman sila, ma'am.
They are so majestic.
Most stable, ma'am. Valence electrons.
Ano sa Courtney?
They are so majestic.
They are so majestic. What do you mean by that? Wala na. Ano sa to?
Have most stable valence electrons, ma'am.
Who is speaking? I cannot actually see who is speaking. Ana din.
Have most stable valence electrons, ma'am.
Okay. So, ani akong himuon? I'll have, kasi ang pinakatama din ha, number 1, they have, kung to ulit yung answer, Nadim?
Most stable valence electrons, ma'am.
Okay. Sige. Ang pinakatama nga answer actually, noble gases has completed the octet rule. I don't know if you can still remember the octet rule. Mo na siyang nagaingon nga for an element to be stable, kailangan in its outermost shell, or that's what we call the valence electrons, kailangan na kompleto na niya ang 8 kabuok. O nagitawag siyang octet rule. Now, the elements class that completed the octet rule are the noble gases. Meaning na sila 8 kabuok nga electron sa ilahang pinaka-last nga shell. So they are stable. And ang result, ana, they don't react with the other elements. So they can exist nga sila lang. So wala sila naga-follow sa tong saying na no man is an island. So paano na to? I'll still give points. So ilista na ko na niya. Singla ko ninyo ugma sa inyong quiz.
Apel may ma'am. Nagsagot kasi kami ng stable, ma'am. So, tama pa rin yan.
Wala ko kabati sa nag-istorya day ka, Brian. Ang ako ang na-acknowledge lang mo lang to ang ako ang
Ma'am, mga kalima ko kasi stable.
Wala ko kabati lagi. So, ano siya nga, you have to be acknowledged first before mo mag-answer. Kay dili na ko mo makita. Mato kagainan ng utan ako. Kinsa na nag-istorya. So, si Nadine de ito. Kay dili na ko
kasi magod, ma'am. Masiro ko, ma'am. Kasi makatutas pa na.
Grabe sa naman masiro, Brian. So, kinsa to ako na-acknowledge kagaina?
Ako, ma'am.
Stephanie to na. Tapos, kita pa.
Ako, ma'am.
Olarte, ma'am.
Aya, Olarte.
Kapa, ma'am.
Aya, Gapa also. So, pero dili ni siya +5 ha, dili man kompleto inyong answer. Ingon man ko +5 kung kompleto. So +3 lang ta tomorrow. Kani lang to, no? Ang akong
Six
giyak
letter, ma'am, 6 letters man ang stable, ma'am. So, +6, no?
Anja? Wala yapil, wala ta na-acknowledge Brian. Wagi ko kabating na nag-answer di ka kay nagsapaw-sapaw naman. So when I asked who was talking, so si Nadine to ang ako ang nakita nga nag-istorya. So kung napa ko'y pangutana later Brian nga moingon kay ko nga plus, dapat magpa-acknowledge din ka. Si Ayan. Aya, I acknowledge you kagay
Ganda lang
na.
na,
You know?
tingog na ako.
Okay, ano ni siya class? Basta naga-screen share man good. I cannot see you. I can see pero ang ako makita lang diri murag upat lang katao. Unya dili na ko makitaan kung kinsa ang naga-istorya. So kailangan mo magpa-acknowledge pag mag-istorya mo nga naay screen sharing. I mean, naga-screen share man gud ko sa ako ang PPT. So dito mo makitaan. Kung wala ko naga-screen share, makita na ko kinsa naga-istorya. Pero kani again, ano yung tandaan ha para ma-acknowledge mo. Para di mo malugi. Okay. So let us move on. So muna itong mga elements ha, and then we have the lanthanide and the actinide series sa baba. Again, they are rare earth metals. Now again, our periodic table, they are arranged according to their atomic number, increasing atomic number. As you can see, you have their hydrogen 1, and then so on, hangtod sa 118. It's just that gibutang nato sa baba, si lanthanide and si actinide series. But nevertheless, they are still arranged according to increasing atomic number. Do not forget, kung saan gina-represent ni atomic number, it's the number of protons. And when we arrange them according to their atomic numbers, actually, makita nato nga, the elements that are grouped together, like sa groups or sa family, they share similar characteristics in a way. And that is what we call, naapod tayo pattern nga makita din ha, and that is what we call the periodic law. Natay periodic law, we will also discuss that one especially sa lecture. But the one that is being credited for the periodic table most of the time is Dmitry Mendeleev. But if we discuss the history of the periodic table, there are actually a lot of names who contributed to the current modern periodic table. But it all started with Antoine Lavoisier. He was a scientist, the first one to set up a table with 33 elements. So siya ang pinakauna nag-set up sa table nato with, pero 33 elements lang ni, and upat lang kabuk ang iyahang groupings. So he grouped the elements into acid-making elements, gas-like elements, metallic elements, and lastly, earthy elements. Now, ang sa kay ano lang, ang kay Antoine Lavoisier, i-appeal man gud niya ang light o caloric heat dinhi. Wait lang ha. Okay, sabang ngiro. We have light or caloric heat here, which are not actually considered as elements. So maulang na siya din ha, ang something na na-appeal ni Antoine Lavoisier na dili dapat ma-appeal. So another notable name is Johann Wolfgang Dobereiner. Ang inyuhang tandaan, ang inyuhang lang tandaan kay taas kaayo ang nakasulat no sa slide, even ang slide sa reporters. Ang inyong tandaan pag makabati mo og name na Johann Wolfgang Dobereiner, let us remember the law of triads. Again, the law of triads. Mo na itong tandaan for Dobereiner. Nga naman, he actually grouped the elements into threes. Kay he observed that these elements na gigrupo niya share the same characteristics also. So like chlorine, bromine, and iodine, gigrupo niya as one. And then, so by threes ha, and then calcium, strontium, and barium also. And then actually, this is also true with the current periodic table. Kaya kanang chlorine, bromine, and iodine, they also belong to the same group. Hangtod karon, nadugangan lang. Kani mang good law of triads lang, tatlo-tatlo lang sila. So that's Johann Wolfgang Dobereiner. And let me add also, kay wala sa akong slide, let me add the name John Newland. John Newland. Ang ato akong tandaan kay John Newland is the law of octaves. So ang gihimo po ni John Newland is he grouped the elements by 8. Mao na law of octaves. So, tatlo na siya ka names. And then we have another person here, si Dmitry Mendeleev. So siya ginapirmi ang makredit sa pagmoingon ka og periodic table. Pero unsa ba ang gibuhat ni Dmitry Mendeleev class? Para mabalaan ninyo ang iyahang gihimo, he made the table, mo na siyang illustration sa table na sa screen. Pero ang arrangement sa mga elements anak class, naka-arrange sila according to increasing atomic mass. Again, atomic mass ang iyahang gigamit to arrange the elements in the periodic table. Tapos na ay mga blanks din ha, because according to him, naapay mga elements nga wala na discover. Kana nga time. Naapay mga elements na wala na discover and he believed na naga-exist na sila with like the following na mga atomic mass. Okay? And then another one, we have Lothar Meyer. Actually, they have the same work with Dmitry Mendeleev. So that is the reason why sometimes if we present the history of the periodic table, ginasabay na ilahang pangalan, Dmitry Mendeleev and Lothar Meyer. Because parehas sila na they arranged the elements in the periodic table according to their atomic mass gihapon. But Lothar Meyer started with just 28 elements and classified them into 6 families by their valence. Okay, when you hear the word valence class, do not forget that we are talking about the electrons found in the outermost shell. So kung pila ka buok electrons ang naa sa pinaka-last na shell or energy shell, mo na iyahang valence. Pero again, parehas og trabaho si Lothar Meyer ug si Dmitry Mendeleev. However, naay mga questions na dili ma-answer ni Dmitry Mendeleev ug ni Lothar Meyer pag-arrange nila using the atomic mass. Actually, ang nag-solve ana kay si Henry Mosley. So mao gini ang pinaka-last na person involved here. Gi-rearrange niya na ang periodic table, but this time dili na by atomic weight or atomic mass. Gi-arrange na niya ang periodic table in increasing atomic number. So I hope na kita ninyo ang difference sa ilahang mga trabaho. But nevertheless, they have all contributed to what is called modern periodic table nowadays. Okay? Questions so far? So this one is, ano lang niya siya, example sa development sa periodic table. Mao ni siya ang mga old ones. So kung nakita ninyo, wala pa na nakumpleto hangtod 118. So napata UUN, UUB, UUQ, and so on. Okay? And then we have here, hinahinay na siya na-discover. So we have here the mga hashum, metnerium, damstadium, roentgenium, and then copernicium, and then though napatay mga UU, but then we have flerovium and livermorium here na na-discover na. Hangtod sa katong modern na gid katong sa first slide na ako, ano gid siya karon ang modern 118 elements. Question so far. Asa dapit inyong wala na sabtan kay atong usabon. Ito gyud siyang usabon. Ug wa na sabtan ha, balik ta sugod. Wala. So mag-assume ta nga nasabtan. Now, arrangement of the periodic table. Again, di-mention ko na ni Kagaina, pag period horizontal. So pareha sa period number 1, we only have 2 elements there, hydrogen and helium. Now, unsa ang similar characteristics nga gina-share sa mga elements sa isa ka period? It's actually the number of electron shells. Class, pag mayroon kag electron shells, this is where we see the electrons. Pag mayroon bugog kag atom, you have the nucleus. Tapos inside sa nucleus, dinha nato makita si protons ug si neutrons. Tapos outside sa nucleus class, dinha nato makita ang electrons. Pero, again, ang gina-share nga similar characteristic sa mga elements nga nag-belong sa isa ka period kay ang number sa ilahang electron shells. So kung maingon kag period number 1, we have hydrogen and helium. Parehas na sila class nga naay isa ka buok nga energy shell. And dira sa energy shell again, diha nato makita si electrons. And then period number 2, we have the lithium padulong dito sa right. Parehas pud na sila na after the nucleus, they have 2 electron shells. So kanang number sa ilahang period, that represents the number of shells that they have. So kung naabot na ka sa period number 7, dako na siya kayo nga atom. I mean, dako na siya compared sa uban, pero di hapon nato makita with our naked eyes. Pero dako na siya in the sense na naa siya 7 kabuok na energy shell. 1, 2, 3, 4, 5, 6, kulang pa isa. Ayan. So, ingana ang kalahian class sa bawat period sa periodic table. Okay? And then, we have groups class. Other names sa group kay family. Parehas lang na sila. Vertical ang ilahang arrangement. Now, natay duha ka klaseng family or group sa periodic table. Family A, again, are the representative elements. So, mabalan, makita na ninyo sa periodic table. Group 2A, Group 3A, Group 1A. And ang katong naa sa tunga, they are the family B or the transition metals. Tapos, naana sila yung mga pangalan class. Group 1A, Alkali Metals. So, balikan na to itong periodic table. Balik ta gamay. Though this one is the old one, but parehas lang man ang ilahang groupings. So, kani from hydrogen to francium, that's the group 1A. And we call them the Alkali Metals. And then, group 2A, this one, beryllium to radium, bemag, gasser, bara. We have here the alkaline earth metals. Tapos jump ka ha, the 3A is here na sa boron nga part. So this is the 3A here, we call them the boron group. So isa sila ka grupo. They share similar characteristics pag isa sila ka grupo. And then we have 4A here. And then nitrogen is 5A, pababa. And then oxygen pababa, they are called our chalcogen. And then 7A, they are called the halogens. And lastly, the 8A, syempre you know this very well, they are the noble gases. So mao ni class ato ang mga family A sa periodic table. Tanan nga naa sa tunga, they are the family B. They are the transition elements or transition metals. And they also have groups here. This one is the group 1B. Baliktad lang hinuon, wala din sila nakapasunod. And then this one is the group 2B. And then baliktad diri sa 3B. And so on. Hangtod 8B na siya class. Okay? Group 1B, diri magsugod kay copper ha. And then group 2B kay zinc before ta mo balik sa 3B. Diri kay scandium. That's how we arrange the periodic table according sa groups. So manila mga pangalan ha. Do ang group 2B ay ang mga B's, ang duha ka grupo lang atong pangalan. Group 1B is called the Coinage Metals and group 2B are called the volatile metals. Balikan nato, di ba ang group 1B kay kaning copper, silver and gold. Copper, silver and gold. They're called the Coinage Metals because they are used to make coins. Okay? Ginagamit natin na sila to make coins. Copper, silver and gold. And then group 2B, we have the zinc, cadmium, and mercury. They are the volatile metals because they volatilize. Nag-volatilize sila. Parehas sa mercury, di ba? Nakaabot pa man ta sa thermometer nga mercury ang ginagamit. Di ba? Pag magbuak siya, mercury is it is like silver pero mura siya liquid, and then after some time mag-evaporate na siya class. So pag mag-evaporate na siya, labi na bagbutang nimo na siya sa imuhang kamot, na absorb na to sa imuhang lawas ang mercury. Okay? So mercury is considered as a cumulative poison. Pag maingon kag cumulative poison, kailangan mag-accumulate sa siya sa body hangtod ma-reach nato ang dose nga mahimo na siyang toxic before siya maging poison sa body. So what will happen sa inyo ha kung mapuno kag mercury sa body? Pwede ka magkaroon og spongy brain. Kita mag sponge ginagamit ninyo maghugas og plato, di ba na ibuslot-buslot. Ingana po ang mahitabo sa brain pag you will have accumulated daghan kaayo nga mercury sa body. Okay? Questions so far? Wala. So let us continue. Again, elements in the periodic table, we have 118 confirmed elements from the first element, which is hydrogen, and then the 118th element is the organoson. Now, how about the symbols? Symbols sa element can be two letters mostly, ang ato ang symbol. And how do we write the symbols? Ang first letter kay capital, ang second na letter kay lowercase. Pero take note, we have 14 elements na one letter lang ang iyahang symbol. Parehas kay hydrogen, H lang siya. Or kay tungsten, W. Boron, B lang siya. So muna siya, 14 na sila kabuok na one letter lang ang ilahang symbol. Now, how do we name and paano ba gi-name o paano ba gihimo ang symbol sa mga elements? These are class the things nga gikwaan sa mga names o symbols sa element. Number 1, many refer to a property of the element and some written from Latin words. So depende, ang uban naay mga elements class nga ang ilahang symbol gikan sa ilahang Latin na word or gikan sa ilahang characteristic. Parehas kay gold, di ba? Ang symbol naton kay gold kay AU. So it has nothing to do, AU has nothing to do with the word gold. Wala kay makita nga A, wala pug kay makita nga U. So gikuha ng AU from the word aurum. It's a Latin word. Ang meaning ana niya shining dawn. Because remember, gold is shining man yun. So muna siya shining dawn or aurum, mao na nga iyahang symbol kay AU. Another example, we have here mercury. So for mercury, our symbol is Hg. So isa pa ni siya nga wala man siya, di nato makita sa iyahang name. But Hg comes from another Latin word, hydrargyrum, mao na nga Hg, and ang meaning anang Latin word na hydrargyrum is liquid silver. Muna kung gingon kagaina, ang appearance mangud sa mercury mura siya silver but more of a liquid type. So mana siya hydrargyrum or Hg. So that's the first one. Kung paano nila gihimo ang symbol and even ang name. And then, the next one, other elements are named for people. So depende na ay mga elements nga giname sila kung kinsay naka-discover sa ila or nalang jud name, nalang jud element nga giname sa isa ka scientist because of his or her notable work sa field. So just like the curium, the element curium is it was named after Marie Curie. So si Marie Curie is a scientist. She won Nobel Prize in Physics and ang iyahang work gyud is more on the radioactivity. So again, an element was named after her and that is curium. That's another one. And then some elements are also named for places. So pwede sa place kung asa sila na-discover. So example, we have a small town in Sweden, sa country nga Sweden, na siya small town called Ytterby. It's a small town class, but take note, we have 3 elements in the periodic table named after that small town. So unsa to na mga elements sa periodic table? We have the terbium, yttrium, baliktad. Four names, four elements di ay. Terbium, yttrium, erbium, and ytterbium. Kana sila tanan upat na elements in the periodic table, sa isa ka place lang sila giname sa Ytterby from Sweden. And then syempre kani siya another element californium, sa name pa lang daan kabalo na ta asa na to na siya first na discover sa California, mo nang gitawag siya Californium. Californium. So pwede po na siya ang reason nga nung ingana ang name sa element. And lastly, some are named where it is first isolated. So dili ni siya about sa place, but about ni siya sa thing or sa mineral kung asa sila first nakita. So for example, we have the potassium. Potassium was discovered in 1807 and named for potash or actually potash. Dira na siya nakitaan na una na isolate si potassium. Thus, potassium na iyahang pangalan pero ang iyahang symbol kay K. Anong K man? Kasi it comes from the Latin word kalium pero ang kalium class ang meaning ana potash gihapon. So, that is the reason why potassium tapos K iyahang symbol. And then another one, we have here the tungsten. It was discovered in 1783. Pero unsa ang symbol sa tungsten? W. So anong W man na siya? It comes from the word wolframite, which is actually a mineral. And dito na siya first na isolate, nakuha si tungsten sa mineral called wolframite. Mauna siya nga iyahang symbol kay W. So again, these are the reasons, class, sa pag-name ug sa paghatag og symbol sa atuang mga elements. Okay? So composition of the atom. Do not forget when you are asked what is the building block or what is the basic unit of matter, it's the atom class. It's still the basic unit of our element because the basic matter, ang pinaka-simple na matter is the element. So natay tatlo ka subatomic particles. So kabalo na mo ani pag proton positively charged, pag neutron walay charge, and electron if negatively charged. And take note of their location in the atom. Pag protons or neutrons, they are both located in the nucleus. And then outside the nucleus, there is where we see the electrons in their shells. Okay? Again, we have two distinct regions sa ato ang atoms. We have here the nucleus, which is small, dense, and it contains the protons and the neutrons. And then aside from that, surrounding it are the negatively charged shells where we can find the electrons. Now, electrons are very light. That is why dili sila actually gi-include sa atomic mass. Diba ang atomic mass na to, protons lang ug neutrons, walay appeal si electrons. Kaya again, ang mass sa electrons are very low. Now, atomic number, mass number, and let's not just discuss isotopes. Let's have that sa lecture. I-review lang nato. Pag atomic number, ang symbol ana kay Z. Always na siya class nga pag isulat nato, this is how we write this. We have the element X, and then the mass number sa taas. Ang symbol sa mass number kay A. Tapos sa baba ang atomic number. Ang symbol sa atomic number kay Z. So do not forget, pag atomic number, it represents the number of protons. Tapos pag mass number, atomic mass or atomic weight, duha ka buok iyahang gina-represent protons and neutrons. But collectively, pag collectively protons plus neutrons, we call them the nucleons. Kaya they are found in the nucleus. So kani, this is just an example. Actually, gipresent po niya siya no, sa atuang reporter. So 8 there is the atomic number. Syempre, O is the symbol. Oxygen is the name of the element. And 15.999 is atomic mass. By the way, for us to be uniform, let's just round off the atomic mass sa nearest whole number. Again, nearest whole number ang atuang pag-round off. Okay? So atomic number again represents the number of protons. Pero di ba pag walay charge ang atuang element, the same sila sa number of electrons. And then ang atomic mass, equal sila protons plus neutrons. Gina-add nato na siya. Therefore, if you are asked about the number of neutrons, minus lang nato atomic mass minus atomic number. So just like this one. So anyway, like oxygen, this is given in the activity. So 8 din ha ang iyang atomic number, therefore 8 pud iyang protons. Ni wala man ni siya charge, so 8 pud iyang electrons. And then iyang atomic number, syempre 16 minus 8 is 8. So that is how we predict the subatomic particles. And then this is for phosphorus here. So 15 again is the atomic number. So maupod na ang number ni protons and wala man ni siya charge. So the same lang ang number ni electrons. Okay? And then how do we get the neutrons again? 31 minus 15. So 16 neutrons. And then lastly, we have another example pero dili dapat na siya sa kilid ha. Sa left side dapat na siya isulat. So 30 protons from the atomic number. And this one is also the same thing. Kaya wala man ni siya charge. And then 65 minus 30, that's the neutrons. So that's how we predict the number of electrons, protons, and neutrons. Now for your assignment, you will be doing this sa inyong assignment. Any piece of paper, as long as mabasa, and then ipasa lang ninyo sa Schoology. So i-publish na ko later ang kung asa ninyo ipasa ang inyong assignment. So we have 1 for oxygen, 2 for zinc, 3 for lithium, and then we have 4 silicon, 5 bromine and boron and 6 kay bromine. So finish this worksheet and turn it sa Schoology na lang. By the way, I'll be giving you a copy of this slide. So kung dili ninyo maapas karon og copy ang inyong assignment, tanawan na lang ninyo sa slide sa Schoology. Okay? When is the deadline? Ha? Kano sa ipasa? Hangtod next week pa akong deadline ani. Okay, so napamoy daghang time to do this next week. Next week pa. Tanawa lang ninyo sa Schoology, makita ninyo dito later kay wala pa na ko siya gi-publish kung asa ninyo ni ipasa. Okay? And then another thing, we have here the ions. If the elements class kay magkaroon silang charge whether positive or negative, we call them now ions. Kay either they gained oxygen or they lose oxygen. So pag mag-lose mangguna sila og oxygen, sorry. Electron, sorry. Electron ang ilahang na-lose ha. Pag nag-lose mangguna sila electron, mao na siya class nga mag-positively charge sila kay mas daghan ilahang protons. And ang ions nga positively charged, they are called cations. So pag maglibog mo, the T there in the cation will give you a hint that cation is the positively charged ion. And syempre, an ion now becomes negatively charged. Nga no mahimo man na siya negatively charged, kay ang element ana nag-gain og electron. Una siya nga mas daghan ang iyahang electrons compared sa iyahang protons. So ang movement plus ha kay electrons ang hinungdan ana. Ang number of protons wala na siya nag-change. Electrons lang. So the reason why we have chemical reactions is because of the electrons. There is movement of electrons, either nag-gain or nag-lose ang element. So we have here examples of the cations. These are elements and polyatomic ions that are positively charged. We have hydrogen, sodium. Most of our metals are actually cations, mga positively charged na sila. But including the hydrogen, though it is not a metal. But anyway, like sodium, potassium, silver, calcium, they are all metals and they are positively charged, so they are cations. Nalang tayo nasagol diri ammonium, that's NH4 positive. Pag ingana gani class, combination siya of 2 or more elements pero na siya charge, dili nato ni siya matawag nga compound ha. Ang tawag nato ana sa ilaha kay polyatomic ions. Okay? Kaya daghan silang klase na atoms, different elements combined together but they have charge. Ang compounds manggod class wala manggod na sila'y charge. Okay? And then we have examples here of our anions. By the way, mostly sa ato ang mga anions are polyatomic ions, just like our hydroxide. That's a combination of oxygen and hydrogen, but it has charge, so -1. Okay? And then most of our nonmetals like the chloride, the sulfide, the oxide, oxygen na to, mga nonmetals na sila, they are our anions, mga negatively charged na sila. So, class, kailangan nato ni sa ato ang next nga activity. Kaya ang next nato nga activity tomorrow kay naming na. So, mag-name na gyud ta. I'll give you some chemical formula and kailangan kamo ang maghatag sa name. Parehas anang tagaan ta mo og NaCl. So, unsa ba ang name sa NaCl? Syempre, sodium chloride. But anyway, I'll teach you tomorrow para mas madali ato ang life. Okay? Wait lang. Ayan. So, again, pag ang atom class mag-gain og electron, mahimo na siya negatively charged. And we call it anion. Okay? Anion na siya. A negative ion is called an anion. So, mahimo siya again negatively charged kay mag-gain siya og electron. So kung pila ka buok iyahang nagain nga electron mo na iyahang charge, -1 kung isa lang, -2 kung dalawa, and so on. Pero pag ang element nag-lose siya og electron, that's the time mahimo na siya positively charged. So again, we call it cation. So kung pila pod ang ilahang na-lose nga electron, mao pod na ilahang charge. Like kung +1, meaning nag-lose siya og isa ka electron. Pag +2, nag-lose siya og duha ka electrons. Okay? So another thing that you have to take note, we have the types of ions here. Monoatomic ion if it only contains one atom. Example, sodium. Sodium, isa lang siya kabuok and it's positively charged. Sodium ion, monoatomic ion na siya. Isa ka klase nga atom. Chlorine, isa lang po siya ka klase. Ca+2 is one type of atom also. Pero katong akong example kagaina, we call them polyatomic ion because they are combinations of more than one atom. Parehas sa OH, that's hydroxide. So combination of oxygen and hydrogen. And then we have the cyanide, the ammonium, and the nitrate. Those are again called polyatomic ions. We don't call them compounds. So I think that's it. That's the end of our slide. Questions? I'll be giving you a copy of this. Wait lang. Let us upload this sa Schoology. Sa Schoology, tanan ang pag-upload class ha. So tanan, pati ang mga recordings dito na tanan i-butang. So mag-quiz ta ulit ugma. Tama, sa inyong kay kailangan ninyo mamawi sa inyong score kagaina kay murag nakamata baya mo ingon ninyo sa inyong score. So please study, go back sa rules sa significant figures. And then after that we'll have the activity number 4. Ang quiz nato class sa activity number 3 next week pa. Isa-isa lang basig mabuang nata. Pahuman na to quiz sa measurements, mag-quiz na punta sa verdict table, mabuang natana. So isa-isa lang. Quiz sa una sa measurements, 7:30. After the quiz, we'll have the activity. And then next week na ta mag-quiz sa activity 3. So napamoy time mag-study. So do not forget the assignment ha nga naa sa slide. Ipasag hapon na ninyo sa Schoology. Later lang nako i-publish ang assignment kung asan ninyo ipasa. Okay, questions? Wala?